All right, guys, example 2. Let's go. Write the system of equations corresponding to each augmented matrix, okay? Then perform the indicated row operation or operations on the given augmented matrix. So there are two things that they want us to do here. The first is to write a system of equations for the augmented matrix that they gave us. So for 2a, looks like they gave us a 2 by 2. What I mean when I say a 2 by 2, I mean 2 rows by 2 columns, okay? So we got 2 minus 4, so that's 2x minus 4y, and your constant is a negative 4. Then the second row, we got 3x minus 6y, and the constant is negative 5. So that's the system of equations that we need. Now, it says then perform the indicated row operation. Here's the row operation. This is red. R sub 2 equals negative 3 times R sub 1 plus R sub 2. So this right here, students, means only row 2 is changing, okay? So when you see the big capital R with subscript, only, whoop, I can't spell only, why can't I spell only? Only row 2 is changing, okay? All right, so it says here, take row 2, we're about to change it by, this right here means we're about to take negative 3 times the value in row 1 and add the value of row 2. So what I mean by that is, let's make a big matrix here to show our work, okay? Okay, only row 2 is changing, so what we're going to do is write row 1 values back. That is not changing. Now row 2 is changing by taking negative 3 times the value from row 1. Well, row 1 currently has a value of 2. Then we're going to add the value from row 3. Well, row 3 is 3 right there. Not row 3, I'm sorry, row 2 is 3. So now we add, oh, why can't I write? There you go, add 3. In a little bit, we're going to go down and simplify that a bit more. And we do that for all the values in row number 2. Okay, so take negative 3 times the value from row 1, which in this particular case is negative 4, and add row 2 value, which is negative 6. Do the same thing. Negative 3 times row 1, which is negative 4, and add negative 5, just like that. So now I'm going to make one more matrix and then simplify this out, okay? All right, so this is 2, negative 4, negative 4. That never changed. Now, let's do the basic math for row 2. Negative 3 times 2 is negative 6. Negative 6 plus 3 is going to be negative 3. Negative 3 times negative 4 plus negative 6, that's going to be positive 6. Negative 3 times negative 4 plus negative 5, so that's going to give us 7. So guys, box this up. Now make sure you guys know how to do your row operations really well, because you need to know how to do each and every row so you can use it to solve later, okay? Now, example 2b, we have a 3 by 3. Normally, when I say 3 by 3, I don't really count this last constant row, okay? So that means 3 variables, 3 equations. So that's what we have to do first, write the system of equations. So that would be 2x plus negative 3y plus 4z, and your constant is negative 6. This is now negative 5x plus negative 6y plus negative 4z equals negative 6. And yes, you can just go straight to negative 5x minus 6y minus 4z. You don't need to do a plus and then a negative, okay? Then your third equation is negative 4x minus 3y plus 5z equals 8. Box that up because that is one set of the instruction, okay? Now, for example, 2B, it's asking us to change row number 2, and it's asking us to change row number 3. So be very cautious, okay? And again, I'm going to make a big matrix here so I can show my work. All right. Row 1, we're not doing anything on row 1. So we are going to copy that over. That's 2, -3, 4, and -6. All right, let's change row 2. Row 2 says take 2 times the value from row 1, which is also 2, and add the value from row 2. So that's now add -5. Whoops, can you see that negative or no? Add -5, okay? Then same thing with the column number 2. Take 2 times the value from row 1, which is -3, and add value from row 2, which is -6. Third entry here on row 2, take 2 times R1, which is from row 1, which is 4, add R2, which is -4. Same thing for the constant, 2 times the value from row 1 plus, this is -6. Okay, and our final matrix, we can do the basic math for that. So next I'm going to erase all of this so I can do that again for you on row 3. So row 3 is slightly different. Row 3, we're changing row 3 by taking 2 times value of row 1, which is also 2, okay, which is here. And then it says here, add value from row 3. So row 3 happens to be -4. Same thing on the middle entry here, 2 times -3, and the value from row 3 is now -3. Same thing, 2 times row 1, which is going to be 4, add value from row 3, which is +5, and one more, 2 times value from row 1, which is -6, add 8, since that is the value from row 3. Okay, so each column, you maintain its position, all right? Now I'm going to make one more matrix right in the bottom so we can do some basic math, and then box that up. So 3, okay. Okay, now let's write 2, -3, 4, and -6 back down because we did not change row 1 at all. Sometimes we do, but in this case we did not. Then let's do some basic math for, I'm going to use red, okay? 2 times 2 plus a -5, that's -1. 2 times -3 plus -6, that's -12. And then 2 times 4 plus -4, that's +4. And my last red answer over here, 2 times -6 plus -6, that's now -18. Let's go to the green. 2 times 2 plus -4, that's 0. And this one right here, 2 times -3 plus -3, that's -9. Then 2 times 4 plus 5, that's 13. And my last green answer, 2 times -6 plus 8, that's -4. And then let's box it up. So the 2 rows that we change were row 2 and row number 3.